Hello, Azubike. Wait, what?
Hello.
What do you prefer me to call you?
Um, it's funny because I was just having this
Zubi.
conversation with family today about what people call me professionally, but it's Azubike, but most people know me as Zubi in the industry.
Zubi.
So yeah, I
Okay.
either one, I don't mind.
Yeah. Okay. I'll call you Zubi then. Let's
Okay.
make it short then. Yeah. Yeah. Since a lot of people already call you that.
Yes.
Yeah. Thank you so much for um coming to participate in this. You're a guinea pig. First one to do this thing with.
Yeah.
Thank you so much. We appreciate your time.
Hmm.
Yeah, so the way this is going to be structured is that I'm going to ask Zubi a few questions about his journey, and then he's going to show us this amazing presentation on the Van Leesten Bridge, Memorial Bridge. I'm saying that correctly, right? Van
Yes.
Leesten
Leesten
Memorial
Memorial
Bridge.
Bridge. Yeah.
Yeah, all right. Awesome. Yeah, thank you so much. And so can you just tell us about your experience with computation? How did you get into it? What was this journey that made you get into computational design?
Very, very interesting question. So just a bit of a background. I have an
Mm.
architecture background. So got my undergrad from Kwame Nkrumah University in Ghana. I'm
Mm.
originally from Nigeria, and then I spent 1 year in Nigeria after graduating 4 year degree. Um, before I then moved to the US for my master's degree. And I took a class. It was called digital fabrication. And the whole point
Uh,
of that class, in fact, I'm actually going to mention a bit of the work I did there in this presentation, but um, that class exposed me to the idea of algorithmic modeling
mm.
because we had an assignment to go from, our you model to machine in order to fabricate something. So we had to work with CNC machines, and then I built this thing, and it changed my view of architecture. Of, oh my goodness, I can go from code to machine and
Mm.
assembly. And so I got interested in um, the code side of things. Then I got hired, and this project was very instrumental to my career, which is why I call it Journey of a Computational Designer.
Yeah.
Uh, and so I then got interested in, okay, so taking a bird's eye view, I can apply this to projects, and that means I can make my coworkers better at what they do. So I started focusing more on process, and
Mm.
then eventually scaled back. And I'm like, if we're working this way, what does that mean for how we should deliver our services as a firm? Um, so got up to the level of being a director, helping the firm coordinate some of these digital technologies. And then I eventually decided to take a step back and see how I can be more effective for the industry as opposed to being with one company. Is it
Mm.
possible that I can elevate the conversation around technology um, so that multiple people are benefiting from
Mm.
that? So, but that has been my journey
Awesome.
so far.
Awesome. Yeah, that's an amazing journey. I mean, it's kind of very similar to mine as well, the way I've kind of got into the technology space. But I'm sure through this journey, you've been confronted with management, and there's been a lot of misconceptions about what this computational design thing is. And so what are the typical misconceptions about what it can do? I think some people think it's magic and it's meant to solve all their problems or something, or
Yes,
what is the typical thing?
you've led me to. So I think people think it's a silver bullet, right? That
Ah.
this solves all the problems in the industry, and I think
Mm.
that's not true. I I I even I think that computation is more about being able to frame your problem than even the solution. I think
Mm.
it's how do you what are you trying to achieve before you even get into um, writing scripts or coding or anything, is what are you trying to achieve? What is the problem
Exactly.
set? What data do you even have before
Mm,
you can even come up with a solution? So I think it's not a silver bullet. It depends on the problem you're trying to solve.
mm,
So I think that's one misconception. I think maybe another misconception might be uh, computational design is Grasshopper. Computational design is not Grasshopper. It's not Dynamo.
it's not
Computational design is an approach,
exactly.
and these tools allow you to deploy this approach. And I'll kind of
Mm,
define it also in my presentation, but I
mm,
think that is a misconception people have. And at the heart of it, I think I'm a designer. So I think another misconception is the computation aspect is more important than the design. I think
mm,
the computation aspect is subservient to the design. I think the design is what is trying to. So again, it goes back to that idea of the problem. Like the technology is helping you in the design, and that's kind of
mm,
how I think about it.
mm. Yeah, awesome.
Yeah.
I think so. Funny enough, I've actually been reading this book by what's his name, Marty Kagan, the product manager. You know, because you were a product manager previously, hey?
Yes. Yes.
And it's I think they teach product managers to fall in love with the problem instead of the solution, right? So I think
Yes.
a lot of those things are coming through in the way you talk.
Mhm.
But there's the one thing that is quite popular, and I think it's very important to deal with, is the issues of sustainability. You know, so
Hmm.
it's quite a huge topic at the moment in the world. And so, in what ways do you think we can use computational design to, to help with this? Is it, if at all?
Yes. So
Mm,
this is a very, I think sustainability
mm,
has,
mm,
it has always been an issue. Now it just seems like the climate conversation seems to be more, because it's gotten political, it's
mm,
now more pervasive. The industry already used to push for the idea of having sustainable buildings, but it wasn't something that clients wanted to pay for already. Just kind of to kind of it's not something that our industry is catching up to. Is kind of what I'm trying to say. But I think in light of that, where computation is concerned, again, it's still the problem. What problem? What aspects of sustainability are you trying to focus on? Is it water usage? Is it how the buildings use energy? What aspects of, so now when you start dialing down, what aspects of energy usage? What are the relationships? What is causing, what aspects of the design lead to energy usage? There are tools out there, like Ladybug and Honeybee and some of these other like pollination tools um, that interplay with Rhino, Grasshopper. But again, the
mm,
thing is, how do you frame it in such a way that the design is, there's a proper understanding of what parameters are contributing to um, energy usage. And so
mm,
being able to frame the this whole thing as a problem of this is what controls energy usage, and I can maybe, if I adjust the geometry of my building or of some sort, I can see how that plays with you know when you're doing like daylighting analysis, energy
mm,
calculations. Those things are um, parameters that you can control, and you're just trying to embed the design logic, sustainability logic, whether it's, like I said, energy or whatever,
mm,
so that you can get like a feedback loop
mm.
as you iterate your design. So I think, again, it goes back to that framing of the problem. Sustainability is a large,
Very large problem. Yeah.
very large problem. So there needs to be subsets. And eventually you can connect all these subsets together so that, and this is where AI comes in, and,
Mm,
large computation that you might not necessarily run on. You might
mm,
not be doing that with Rhino. You might be using Rhino as an interface or something, and you're pulling from the cloud, and not to get
mm.
into that, but yeah, I think the critical thing is knowing how to frame your problem. Sustainability is just another one.
No, I see. Yeah,
Yeah.
that makes sense. And I'm
Yeah.
sure in your practice, in Future Breed, in your clientele, you're having to deal with some of these problems as well. I
Mhm.
mean, so what practical ways, just to frame it for the audience, are you seeing that you're applying computational design
Computation.
to your
Um,
work?
I think so. I mean, this project is
Mm,
one in that you're dealing with complex geometry, right? So, and I'll say I'm not necessarily a fan of complexity for complexity's sake,
mm,
uh, but you can't also separate functionality from aesthetics too. Like people are, like there's a certain type of aesthetic that appeals to people, like how it looks also has an appeal. So there's the complexity side of geometry, whether functional or aesthetic. But then there is also, interestingly, project management. What I mean by that is you have all of these project metrics. Um, how are you taking advantage of that data and making sense of it, in
mm,
such a way that you can then make better decisions about your organization? So
mm,
that's writing tools, bespoke tools that help you understand, how successful your projects are being, how successful you are at staffing, uh, for certain projects. So the idea of the problem, the solution, you have all this data. How are you
mm,
connecting different data sources together?
mm.
Um,
Are you
and now,
integrating AI? Sorry, are you
no.
integrating
So
AI in any
no,
of it?
I'm not integrating any AI right now. The clients I work with don't necessarily have problems that need AI to solve in the moment. But
Mm,
as they start to make sense, because you have to, I will say, crawl before you run. And
yes.
a huge part of that is making sure that you're collecting your data in a way that would be beneficial for AI along the line.
Mm,
Most people don't even have well structured data to leverage AI anyway. Um, and so I'm not doing that now with my clients. But another thing is construction drawing automation, right? So there are aspects of the process that are repeatable, and
mm,
so helping identify what those things are and helping automate, some of those processes, but then also embedding fabrication intelligence into, um, some of the like models that are created. So as you are modeling, this project was an example where, so I didn't directly embed the fabrication intelligence. That was something the fabricator did. But on some other projects, when you're working with less sophisticated fabricators, you're able to capture their process into how you write your scripts, so that
mm,
when you're developing those scripts, you account for how it's going to be made. Um, so
mm,
that's also another way I
mm,
implement computational design
mm,
with my clients.
mm. So if I'm from all the things you're saying, I can see that computational design, it's before you write the scripts, you need to understand the process. Like I think you've alluded to it. So
Yes.
it's a lot about before you get into all the programming and doing any Python, step back and actually understand the process you're trying to automate.
Yeah.
I think that's what you're also adding, saying that a lot, quite a lot.
Yes.
Yeah, yeah,
That is accurate.
very important. Yeah. Okay. And so, I mean, I've got students here, and a lot of them, I know when I started teaching, they were struggling, and it's just like, how do we get into this? It's so
Right.
difficult. What advice can you give them? How do they, stay the course and not give up halfway? Because it is difficult. I'm brutally honest with them that it's a tough thing to learn. You have to be consistent, but what advice can you give them?
I
So,
I I think everything, well, I say this carefully. Most things that you start out for the first time seem difficult. And so there's this rule of having to put in 10,000 hours into something that you do before you become an expert or a professional at it. So I would say, for starters, one, you're not alone. And there's a large community of people who, I don't know if you're aware of the grasshopper community, or people who are available, even people like myself who are willing to engage the questions that you have. May not solve the exact problem for you, because that way you don't learn,
Mm,
but would help you frame your problem again in such a way that what you're now dealing with. So step back. I always tell students, because I teach as well, is it goes back to that: write out the problem. Just write it out. Don't worry about the script yet. Write out the thing you're doing, so that when you now get into the scripting environment, you're just looking for what thing does what. I think that's something
mm,
you can find on Google, like, oh, I'm trying to do this. Or you go on the Grasshopper forum and you talk intelligently to the community of, hey, I have this shape or this data input. How do I do X? So your question comes across as, this is somebody who's not trying to just trying to find someone to do their work, but
exactly.
they
Yeah.
know what they're trying to achieve. They just need someone to point them in the right direction of, oh, use this tool. This one does this. And now you have that, you learn from it, you experiment, and you keep growing. Like, you keep growing. But don't be discouraged. Start small and then walk your way. The complex stuff is just a group of simple stuff that have formed this complexity. And
Mm,
I would say over time, you would also find ways to make that complexity even simple in and of itself, because you're like, oh, I could have done this whole thing maybe with two other things, because your knowledge is growing.
mm,
So start simple. Um, there's no stupid question. That's also what I encourage. Ask your questions, and there's a whole community that's ready to answer.
exactly. Yeah, and also learn how to define the problem, like what
Yeah,
you're alluding to,
yeah.
how to break the problem down into little segments.
Mhm.
That's why I'm also trying to teach them, to define the problem and dissect it.
Yeah.
It is it's a big part of computation, right?
Right, right. It's like you're trying to draw a line. A line is made up of 2 points. Okay, so that means, where am I getting the 2 points from? Okay,
Yes.
so you start to walk backwards to go forward. Yeah.
Mm. Awesome. Well, so for the audience, just know that you can add the comments or your questions into the chat, and towards the end of when Zubi's presentation finishes, then I'll ask him the questions, or I might just unmute you so you can ask the questions as well. Great. I think we can get into it. Yeah.
All right. So thank you everyone for joining this presentation. It's on the Van Leesten Memorial Bridge in Providence, Rhode Island, here in the US. And in as much as this is a presentation about the project, and especially about how computation was used on the project, it's also about, honestly, how things got very serious for me coming out of school. I know there are a couple of students here. So um, again, just a quick introduction. Azubike is my name. Most people know me as Zubi, and I'm the founder of Future Breed. It's also a fractional digital technology director. What that means is people hire me to help them develop their strategy for their organization for a period of time. And then after that, they can engage me again if they want to, but I'm on a part-time basis working with multiple different firms. And similar to Bio, I also co-founded with a bunch of other people, Computational Design Detroit, which is like a Detroit-based computation group that helps other companies it's a subcommittee of AIA Detroit, which is the American Institute of Architects. Helps the member architecture companies and people in there figure out how to leverage computation. And then every summer I teach at Lawrence Technological University, which is where I attended for grad school, and I've been teaching there for a while now, about 5 years. Also, this presentation is going to be based on my time at Inform Studio, which is where I was the director of digital technology, helping the firm leverage technology. So if you want to connect with me, just scan that QR code. I have it at the end of the presentation as well. So we can always do that. So I typically start these presentations with some kind of wisdom from other people around the world. In this case, just I'm glad that this is a South African group, and there's someone that I really respect in Yolua Aboyeji. He's a tech investor out of Nigeria, but he's not only doing he's not just local to Nigeria. He said tech is not code. Tech is a productivity multiplier. And that stuck with me, because I think you've been able to hear the undertones of what I've been trying to explain, is that if technology is not helping you be more productive, so by productivity, it's you're able to take on more things, you're able to take on things, do things quicker, you're able to handle more complex things. If technology is not allowing you to do this, then your code is useless for the most part. So I hope you hear that as I talk through. So going into the project, this is the Van Leesten Bridge. It was designed by Inform Studio for the city of Providence, Rhode Island, and was completed in 2019. And this project was meant to be like a visual symbol of renewal for the city as they sought to connect, if you notice, not two, but like several, maybe about 5 prominent neighborhoods and institutions within the city. It's about 350 feet, which is about 91, I think, meters, something like that, with a total square surface area of about 1,400 square meters. And then this bridge has about 250 unique facade panels, which is kind of what I'll be focusing this presentation on today. But also, the bridge used to be a pedestrian bridge. And so the whole point was the city, because they were trying to connect this to multiple portions of multiple neighborhoods, the proposal was more of a substantial switch from vehicular to pedestrian and cycling a bridge, right? And so what you have was this competition that the city put out, and Inform Studio put out a proposal. And the Providence Bridge, it was intended to not just be a bridge, but be some type of spatial mediator between urban and ecological spaces, and then function as an integrated series of programs. So if you notice, you have in this area like seating, you have like people being able to cycle on one point, walk on another point. There's even like benches. So it's not just a bridge, it's a place. And underneath this bridge was a restaurant, which I'll also show pictures of. That's just to give you a sense of what they were trying to achieve with the project. If you want to read more about this, you can scan this particular QR code and to take you to a link that talks about more of the history of the competition. And Inform won this competition. I think it was about 2008 that they won this, sometime 2008, 2010, one of them. And then one of the proposed programs, like I said, for this bridge was a floating restaurant. Um, who doesn't like good food with, good views as well? But like with most projects, dreams get dashed by budget constraints. So this restaurant actually never happened as far as the bridge is concerned. But my reason for showing this isn't necessarily because of the restaurant, but it was because of the complex formal gesture that the architects of Inform Studio were trying to achieve, right? If you notice in this corner of the bridge, you can see this double-sided or double curved, I would say, geometry that seems to span across like several portions of the of the bridge, almost giving it like a boat construction vibe. But the it's interesting because you know the project kicked off again in 2013, which is when I was hired. But up until this point, the model existed as a 3D Max model. I don't know how many of you know about 3ds Max, but it is not an architecture software. It is for animators and I think potentially people who, yeah, it's mostly animation uh, uh, people, and I think uh, they use it for. I don't know if they use it for games, but it's not something you can build from. It's just illustrative, right? And so it's by Autodesk. Autodesk owns it. So at this point, the it only existed in that model, and so what you end up having is that in trying to remake, in trying to create a buildable model, there was a realization that this thing was just more or less photoshopped. It was a visionary image that was meant to win a competition. And so essentially, it'll be what today we would use generative AI to kind of create using Dolly, Veras, Midjourney. You put in your whatever that input is, input image, and you might just create um, some evocative, you know, nice looking project. But the problem is, how do we build the model? So it's a caution. Don't show your client something that you generated through AI if you don't necessarily understand how you're going to build it. I heard my then bosses say this to one another of how do we build this? This was the start of my journey in that there's a problem. Keep your ear out for the problems that go on in your organization. And even if you're a student, try to tap into what's happening in practice. Like, what are they struggling with? Such that you're able to start thinking about how these tools can solve real life problems and not just academic scenarios. So, and it may look like I'm calling out my then bosses, but no, they actually stuck with the vision. They could have been like, we might need to tweak this because we can do it, but they stuck with the vision. And so that challenge was there, though, of how are we going to build a model? And so this is what the actual 3D Max model looked like for that portion. You can see no one can build from this. So this is a problem. How do we get from this to this? This is the actual model that we ended up finishing. That shows all the railings. It shows the skin double-sided on some of them. Some of them were just more planar surfaces. Gives you an idea of where the some of the expansion joints are. The paneling shows you the deck. All of these were modeled. And this presentation is pretty much going to be about how we're able to achieve that facade. But in order to build this, I had to tap into my past. And this was the project I was talking about that I had to deliver in school. And it was a bench project I chose with my teammate, Mikhail, um, to do a bench. And the whole point is we had to push the limits of very simple materials. This is just plywood, but we're able to create this gesture um, that made this hard material very soft looking. And we were only able to do this because we had control of not just the design, but the fabrication process. So the design was done, but then we took it to a CNC machine, which you can see the machine on the far left, cutting up each profile. And then that's me in the middle, sanding and cleaning up the edges so that, you know, when you cut these things out, they can be sharp on the edges. So just buffering it out, and then the assembly on the right. And because I had done this, I thought to myself, hey guys, I might be able to take on this project. Again, think about this from a bench to a bridge. Something very poetic about that. But again, keep your ear out for the problem. And because of that, my bosses were like, oh, okay, so how about you try? And initially, all we had to work with were this plan and these three sections. That was to capture the idea of what they were trying to do. And originally, I started doing this in Revit. It worked to the point that they were able to see something, but eventually Revit was not necessarily the best at handling complex geometry, at least at that time. So we switched to Rhino. Now, what you're seeing is this is 10% progress into the modeling. We used Rhino, and this is what some of the imagery looked like. The problem with this is I found that I was repeating a whole lot of processes. And you can imagine, just even if we go back to this image, you're going to be dealing with a lot of like offsets or fillets, right? Fillets along different aspects of this geometry. And so there was a whole lot of process repetition. There was also slow response to design changes because I'm modeling this manual. At this point, this is just a manual. What I call manual is I'm shifting Rhino surfaces. The moment you have an engineer change something, I have to redo that. And it was just very slow response to that design change. And the form was unpractical. What do I mean by that? In as much as maybe you can see some of the complexity in the form, when you have to fabricate it, you don't necessarily want, if you don't have to fabricate things that, will I say, are custom, you want something they call a rationalization of geometry, is you want to use as much repeatable portions as much as possible. That allows you to come under budget because there's scale of reproduction of the same thing. However, using Rhino directly, some of the undulation of the form was very, very impractical. And here's an interesting one: the origin point. We had issues with aligning engineering information with architecture information. This this was a good thing that ended up having me go see Bureau Happold, who was the engineer on the project. I had to go visit New York. So that was a great outcome that came out of this, because I was based in Michigan. I'd never been to New York, and I got to visit New York because of that. So good things that can come out when you also, say you can do certain things. But at this point, there was no grasshopper involved, right? No computational thinking involved. So I told you I was going to define computational design because at this point, I recognized I have to deploy computational design on this project, computational thinking. And I think of it as a methodology, a way of thinking that involves the creation of design systems. When we're talking about environmental sustainability, these are design systems. But in this case, they're powered by data and code that captures and simulates design logic. So it's a way of thinking that involves the creation of design systems that capture and simulate design logic, but it's powered by data and code. Designers, architects, even engineers, especially the ones who are experienced, right? They've done things over and over, and things are very intuitive to them. It stays in their head. But when that person leaves the company, so goes, that way of thinking. But how do you extract the thinking, the thought process in your head in such a way that you can then simulate that with the computer? And that, to me, is what computational design is about. And so, like I said, I was repeating processes here. How do I capture those processes in a codified way? Because it's about relationship and constraints. Relationship between geometry, constraints that come from geometry, but also come from construction limitations. You have to capture those things into your code. And so at 30%, this is what this looks like with Grasshopper. That's the Grasshopper logo. It's not a bug on your screen. And at 90%, you notice kind of the definition that starts to come out from the geometry. And then what we had, how did we figure this out? So if you remember that plan that we initially had here, if I could go back, I decided to break this up into segments. And so that's what you're seeing here, color coded. Each segment had a different profile, which is what you're seeing in the base. So we have 5 different profiles for 5 different segments of the bridge. And the whole point was, see, now we're framing the problem in a way that we can control it. So here's an example. I just left the script here for visual purposes. Typically, I don't like to, just in case it scares anyone, but just to give you an idea of what the script looked like. Now you can see on the right-hand side, the designer doesn't need to see the script. We embedded the information in Rhino, and so they're pulling these toggles. So you can imagine if the engineer, on the gray portion of things, that's the primary structure. So if the engineer ever changes that structure, all the designer needs to do is adjust that slider so that it doesn't interfere. And if they need more softness with the form, they can adjust the radius so it starts to soften. So all of a sudden, we've embedded the logic, remember? Like we've embedded the logic into the script, and so the designer can be more productive. See, it's not just about the code. They don't even have to see the code. They're just being more productive in the design. And here is a more complex portion of the bridge, which has the double-sided curve to it. It was really controlled by 3 curves. And those curves in and of themselves could have been parametric. I can't remember if it was now, but it probably was. And what you're seeing with this dashboard is it's giving you the ability to adjust, but it's also giving you the distance from the primary structure, because you don't want to be too far, because then you need longer members to connect the substructure for the facade to the primary structure. So while you're making these adjustments, you can actually see things like how deep or how apart are they. And you can, while you're also dealing with some of the aesthetic nuances of the project, because again, it's not just about the functionality. It's also about how does it feel? What does it do to the eyes as you see it? And so that's what, we're able to use Grasshopper to do. Again, you can see the script and just how we broke down the problem in order to solve it. And on the flip side, this is really what we came up with. We came up with these panels, but we also came up with the code. And so that leads me to this point. Computation leverages data, not drawings. I don't know what things are like in South Africa, but here in the US, you still need drawings because they need to be approved. So we did give drawings. So these are shop drawings required for the just approval process and all of that. But look at how complex this project is. There's no amount of dimensioning that's needed, because these things were going to be fabricated in the factory and then assembled on site. So it's an off-site construction system. But this was necessary to be done for approval. So as we think about the future of our industry, what if this approval could have been done in the model and nobody needed to create drawings? That's something that's very critical for us to think about. Again, it's what aspects of our process can be disrupted by design. It's how we should be thinking about this, and not just technology what aspects of the process can be disrupted by technology, sorry, not design. So as we think about our processes, it's very important for us to think of, is there technology that can help us do things quicker, be more productive? So because checking drawings is a waste of time at this point. And so this is what the model look like. Each and every one of the substructure, the fabricator generated using Grasshopper, using code. So they took the skin and they built their code on top of the code we already had for the generation. So see that collaboration is, you don't want to waste. If you think about this in a different world, you would construct the model. The fabricator will take your model and reconstruct it for their own. So now you've duplicated processes, but now they can just build code on top of the code you already had. And that's how they're, able to construct all of these armatures and like structural support that was then going to be attached to the primary steel structure. And that's what the process looked like. I didn't even talk about the material. This is Ipe wood, so it's very durable, but it's hard to work with. And so because you don't want to do a lot of work on the wood itself, we use standard planks, but a lot of the fabrication was on the steel connection. And so what you have on the top, let's think of the top 3 images, is just the wood attached. It goes from the wood planks to them being attached. If you notice, they're the same size, except in some areas where you have to trim them. And then you see it on site assembled. And below, you see the water jet cutter, almost like the CNC machine that I used in my project, but this one is for steel, and you can do other things beyond steel, but it's cutting out the steel brackets and all the other connectors necessary to form the the structural support for the facade panel itself. And then on the far right, you can see the assembly process where they brought all of those things from the factory onto the site. So you can imagine you're now dealing with conditions where safety hazards are off the, like, people are safer because you're doing these things on site, off site, and you're going to assemble on site. So I'm sure whatever insurance is attached to this whole process is going to go down. I don't know for a fact, but I don't see why it will not, because you don't have people working on site, which is they're more exposed to potential harm. Also, the sequencing of design. While things are happening on the site with the primary structure, things are happening off-site on the fabrication end, because now you have things that can overlap, which affects the amount of time that the project gets completed under. And then you're also dealing with things like the material waste. Well, when you go through this process, you're accounting for the right amount of time or right amount of material usage, that you reduce waste because you can plan for ahead of time. So these are some of the benefits, again, of thinking about how am I leveraging technology on a project. It's beyond the design, but also on the construction side. So think about the whole value chain of the industry. In this case, design and construction. You want to see how you can leverage technology across that whole value chain. So at that point, we went from this, if you remember, to this. This really shaped a lot of the other projects I did at the company. And you can imagine, even beyond the computational aspect of things, from a project standpoint, this project was able to really help the city achieve what they were trying to achieve from an economic standpoint, and activating the waterfront of both sides of the river. And if you want to know more about the economic benefits of this project, you can, click on that link. All the images here were provided by Inform Studio, just to give a shout out to my former employers. And some of the imagery was also provided by Situ Fabrication. Those are the people who actually did fabrication. We collaborated with them on that. And Steve Crew, who took the photos, shout out to you, because he lets me use some of his photos for free. So I appreciate that. Again, to bring it back, tech is not code. Tech is a productivity multiplier. So you can see how it's multiplied productivity for the design team, productivity for the construction team, but you can imagine what that then did for the client. All that benefit goes to the client. And with all of that, we should start to shape what value are we contributing for the client. And you can imagine with a panel system like that, it helps with maintenance. If they need to fix something, they can take something out, fix it, put it back, everyone's happy. So that's all I had. If you have questions or even thoughts, maybe I said something that's wrong, I'm open to learning new things, but I hope this has been beneficial for you. Thanks.
Thank you so much. That was very inspiring, man. I enjoyed I thoroughly enjoyed that. So for me, one thing, I mean, this project looks awfully intricate. Those fabrication drawings are insane. I didn't know all those steel rods and all those like that those steel beams were inside that bridge. I mean, it just looks like a timber structure for me.
Exactly.
Like,
Right.
Yeah. So that was probably one of the things you guys were trying to achieve, eh?
Mhm.
Correct.
because we knew it
Yeah.
was a steel. It was a steel because of the span. We knew it was going to
Mm,
be steel because you're also
yes.
dealing with like salt in the water. You're not
Mm,
going to overly use concrete, So there's some constraints with am
mm,
I right? Was there salt in water? I need to verify that one. Maybe I'm speaking
mm,
about another project, but I know steel was just the way
mm,
we're gonna go. But
mm. Yeah. And at that time, you hadn't really used Grasshopper, correct?
yes,
When
because
you,
I wasn't part of the project for the competition,
yes, yes.
right? It was only they won the competition, and then 2013 was when it was now going to be constructed. And so, it was almost like they had a conceptual model. They didn't have a schematic or a design development model to then build a construction drawing off.
Okay. Please, if you guys have questions, add it to the comments, but I'll ask my questions. So how long did it take you to make this whole workflow? Because for me, it's crazy to think that you had almost zero experience with Grasshopper and you made this. So it's kind of like my problem where so we did the Baha'i temple. I had zero dynamo skills, but we
Right.
wanted to automate this tiling thing that had like 9 different colors, 3,000 square meters of tiling, and
Wow.
we couldn't do this manually, or it would have taken a year, right,
Would
to
have,
do.
yeah, right.
But I had to figure it out. So like and it worked, which is crazy. So how long did it take you to do this, and how did you like figure this out?
Good
It's
question.
it's
So
crazy.
I can't exactly remember how long it took. All I know is, as far as time is concerned, I had deadlines that I was working with, like
Mm,
specific milestones. It varied from time to time. Um, but I think what might be beneficial is like the second question of how did I figure this out? Like I said, I
mm,
went from the bench. I knew what I did on the bench. I knew how to
mm.
navigate my way around it. But I had the Rhino Grasshopper community, and I was asking,
Yes.
like, you might even go there now. You might see some of my questions concerning this project. Um, I was just asking people, hey, I'm trying, not that I'm trying to achieve this project, is I'm trying to achieve some small subset that I know will take me in the right direction. Um, how do I how do I do how do I do it? People answered, and I took that and applied it to the area where I didn't know. And so it was a combination of learnings from the community, learnings from how somebody else solved another problem in the community, that I was able to take that idea and
Mm,
mash it with what I was trying to solve and just what I already knew. Um,
mm,
in
mm,
that process. That's how I came up with the solution. But I don't know how long it took. Um,
mm. Okay. Yeah. I mean, it's the same thing with me. I had to go to the community because there was no way I would have figured this out on my own. And that's
yeah,
the thing people have to learn. You don't have to just struggle through it yourself. Um, I didn't know how to start. I asked very detailed question, showed
yes,
images to the community of I was trying to achieve, showed what I had tried, and someone came and he actually gave me quite a bit of the script. He
mm,
spent maybe, I don't know, nights trying to do it because I
yeah,
asked my question correctly, and then I modified his script to make it work for myself, right?
exactly,
So
exactly.
feel free to ask questions.
Feel free.
Okay, we have a question here from Theo.
Mhm.
How do you plan around deadlines when developing a script this complex? When you
Oh,
have tight deadlines, how do you plan around it? Because
that's a great
so
question. Do
I'm
you?
sure some bosses might think it's a waste of time. Why are we doing this grasshopper thing instead of, just getting straight into it? I'm sure that's probably
Yeah.
what he's asking. Well, so how do you plan around it?
So with this project, I learned because it's almost like I was figuring things out as I was developing the script. But when I did like a retrospective and started growing and learning more about like the project management side of things, it was how can I reduce my risk as I start
Mm,
this project? It's about the risk. So what can I start before I actually start coding? And that's where the questions came in. How am I going to build this? How do I build this mentally um, before I actually build the logic for it? Because what
mm,
you can now do is you can document your steps, or not necessarily your steps, but like the different chunks of, okay, this is what I need to do, and you can phase it out. I'm going to do this. This is going to take me maybe 3 hours. This is probably going to take me 1 week. This is probably going to take me. Now, you're doing all of this. You haven't written any code. No script is involved. This is just a mental exercise. And you want to give yourself some room for, you might take longer. Sometimes you might do it quicker, but you want to put in that timing. And the more you do it, the more you know yourself. And in my case, like I got to the point where I had like a team. So I even knew what people were capable of doing. So before a project starts,
mm,
I get brought on the project, not after the fact. Because what that means is I can then tell, hey, this is what you're trying to achieve with the project. Give me some time. Let me figure out what this project needs. And then I'll go through that process with my team of figuring out, for us to do this, we need to have this, we need to have that, we need to. So we de-risk the project um, from an intellectual standpoint of what don't we know that we need to learn
mm,
to be able to do this, but also this is how much time we think it will take. And that way you can communicate it ahead of time so that when you need
mm,
to get the money from the client or when you're putting your proposal together, you already have accounted for that much time in the project.
mm,
Because what ends up happening is it's an afterthought. And so you've already communicated to the client, this is how much your service is going to cost. But then when you start implementing these processes, you start eating into costs that weren't accounted for. So you want to go through this process so that you can account for these things ahead of time. I hope that answers your question. That's how
mm,
I ended up going about it post this project.
mm. That makes a lot of sense. Again, pre-planning. Before you get into something, just pre-plan it, and so you can strategize, and in that way, there's less arguments in future as well. You're covering
Exactly.
yourself.
Yeah.
You're
Yeah.
covering yourself. Yeah, yeah. And yeah, so but the issue of management, so convincing, I don't know, maybe it was easier in your studio to convince them to buy a Rhino license, I mean, this thing is, I mean, it's a once-off license, but people would
Yeah.
just, it's hard to convince people that these tools are necessary. And the computation is still very niche, right? It's still, at this point,
Yes.
not a
Yes.
lot of
It's
people are doing
still
it.
deep.
Even
Yep.
in South Africa, yeah, it's a very niche thing. How do you go about convincing people that this is the right way to go? Don't just build, let's not just build this on Revit, or let's not just draw all this by hand or something. How do you convince them that it's worth the time doing this?
Have
And
you
I,
have you
yeah,
guys
sorry, go.
heard of there's something, so this is from a product management standpoint and just software in general. There's something called your MVP. It's like a minimum viable product. Um, the whole point is you're meant to use less time to develop the MVP. You're meant to use less resources, um, but you want to get it to a point where it communicates. It's communicating for you. Like you are using it to communicate the idea for something much larger. Um, but you need to start from somewhere. In this case, I think there's a bit of biting the bullet on the part of you, the computational designer. So in my case, I have something to show, that bench,
Mm.
right? But that just happened to be something I was trying to get grades for. But there are other things where I'm like, I think there's a better way to do this, guys. Okay, I'm not going to tell you about it right now. I'm going to try and figure it out. When I solve this small thing, my plan is that this small thing is able to convince you of a larger thing. Right. So I
Mm.
think you have to pick computational. So I gave a presentation recently of computational designers need to think like product managers, in that
Managers.
you need to think about the problem. Find a problem that people identify with. They actually agree that this is a problem. Solve it for them as little of the problem you can solve, and then use that to build momentum. That
Mm.
that's the way to possibly go about it. Now, there's also a cultural aspect to it. It's not just on you. It's also on leadership to be able to ask themselves, why do you even exist as a business?
Mm.
And part of being a business is to make money, and you make money by either bringing in money or saving on your operations. So if you can communicate also um, how this is saving on operations or how this is potentially going to bring in more revenue, leadership should also be trying to do those things in an
Mm.
ideal world. And so if you can meet them where they are, because they're dealing with a whole lot and they can't even think about technology sometimes, which is the opportunity, not a problem for you. The opportunity
Mm.
is you can now be the person who provides them with insight on, hey, we can use technology to do this for the company. So leadership needs to be top down and also bottom up. But I think leadership needs to challenge themselves of what kind of culture in your organization do you want to have? An innovative one, or you just want to continue doing what you've been doing? I
Mm.
think that one is that's in what I do now. A lot of it is change management, trying to make
Yes.
sure leadership recognizes if you don't do it, you're going to go out of business. It might not be today, it might not be tomorrow, but eventually you will go out of business in several ways. One, your clients decide to go to somebody else who is cutting edge, or your staff decides to leave you because they've gone to someone else who's cutting
Exactly.
edge. So now you can't do the work which your client frowns on and isn't happy about. So either ways, something is going to happen with your business, and
Mm.
that's the challenge
Mm.
I pose to clients.
Yes.
I mean, yeah,
And the other yeah, and the other way around as well. As a an employee or a student who's trying to get a job, you can set yourself apart by learning these skills, right? You're more
yes.
attractive if you actually know more than the other person.
I think
So doing things the way it's been done for decades is not going to get you anywhere.
right.
So you know, so
That's a
it's
good point.
yeah,
Because if you
yeah,
think about it, like if for
mm,
some instance there was COVID happened, right? And businesses needed to cool off, clients weren't coming before. Unfortunately, people have to be let go as a result of slow business. If you have this skill, they're not letting you go immediately. So you have to think about like what skill set can put me in a position where I'm really valuable to the company. It's
mm,
not design, there's a certain type of design skill that will keep you there if the company is interested in design, right? Hugely interested in certain types of design. But when you have this type of thinking, it's beyond, you're able to do a lot with small because
mm,
of how you think. And that is very valuable.
Yes, yes. I don't have any questions. Do you guys have any questions? If you do, please add to the comments. Yeah. If not, we will just end off.
All right.
Zubi, I don't know if you have any more nuggets to add, and then we
No,
can just
except if you have questions, feel free to reach out on LinkedIn. I I like to entertain these questions. I like to even get challenges, like, because I think we're all growing in this space and we help each other sharpen our skill sets and thinking. Yeah.
Thank you so much for coming. Really appreciate it. It was very enlightening. It was great to see that project, and it's amazing to see that you did that. Yeah, without any experience, prior experience. And yeah, I'm sure it's made you grow. And I hope this this whole webinar, brings more attraction to your business. So yeah,
Thank you so much.
thank you so much.
All right.
Thank you.
Bye, everyone.
Cheers. Bye bye everyone. Thanks for coming.